All right, so now let's look at another special triangle. All right, so this is known as the 30, 60, 90 triangle. All right, so this is a triangle we're talking about, where one of the angles is 30, one of them is 60, and the other is 90. They should add up to 180 degrees. If you put them back to back, you'll get an equilateral triangle where all the sides are the same. But right now we're just focused on this one because we want to find the sine, cosine, and tangent of 30 degrees and 60 degrees. So let's start with 30 degrees. All right, so sine of 30 degrees, all right, here's our 30. So again, we want to think about the side lengths in relation to this angle here. So when we find sine of 30 degrees, we need the opposite side of 30. So opposite of 30 would be 1. And the hypotenuse is always the hypotenuse, the longest side. So sine of 30 degrees is 1/2. All right, cosine of 30 degrees. All right, we need the adjacent side to this 30-degree angle. So adjacent to that is the square root of 3. And we want to divide that by the hypotenuse. Adjacent over hypotenuse. So cosine of 30 degrees is root 3 over 2. All right, and then we want to find tangent of 30 degrees. Opposite over adjacent. Opposite is 1. Adjacent is root 3. All right, I see a radical on the bottom, so we're going to go ahead and rationalize the denominator, which means get the square root out of the denominator by multiplying the top and the bottom by that square root. So we get square root of 3 on the top and just 3 on the bottom. Okay, so we were able to find those 3 trig functions of 30 degrees. Now let's do the same for 60 degrees. I'm just going to put a line here. All right, so our 60-degree angle is here. All right, so a sine of 60 degrees, all right, thinking about being down here now, we want opposite over hypotenuse. So sine of 60 degrees is root 3 over 2. Cosine of 60 degrees. All right, so we need adjacent over hypotenuse, so that's 1/2. And then finally, we need tangent of 60 degrees. Opposite over adjacent. Here's my 60. Opposite is root 3. Adjacent is 1. So the square root of 3 is tangent of 60 degrees. All right, so what if we're given some information about some of our trig functions and we were asked to find information about all of them? Okay, so it says given sine of theta is 2 divided by 3 and cosine of theta is root 5 divided by 3. Can you find the 4 remaining functions? The answer should be yes, we can, because this gives us everything we need to know about our triangle, or at least the ratios of our triangle. We know that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. We have all the sides. So we could draw a triangle if you wanted. You also could do this without a triangle. I'll tell you how. All right, so here's our right triangle. This is supposed to be an angle, theta. And we found that sine is 2 over 3, so the opposite side should be 2. The hypotenuse should be 3. Cosine is root 5 over 3, so that tells us the adjacent side should be root 5. Hypotenuse is 3. So we have our triangle. We can now find the remaining trig functions. All right, so let's start with cosecant theta. Okay, so there are a couple ways we could do this. We could remember that cosecant is hypotenuse over opposite, or we can remember that it is the reciprocal of sine theta. So either one, reciprocal of sine theta is 3/2. All right, and so secant theta is the reciprocal of cosine theta. So 3/5. I should probably rationalize this denominator. So I'm going to multiply the top and the bottom by √5. So we get 3√5/5 for secant theta. Okay, so tangent theta, we will soon learn that it's sine over cosine, but for now, we can think of it as opposite over adjacent, so 2/√5. Rationalize that denominator. Okay, and then finally the last one, so we only have 4 left, cotangent theta. Remember, cotangent is the reciprocal of tangent. All right, so we can just flip this one. However, it may be better to flip this one so we don't have to do any extra work. So √5/2. Okay. All right, and so these, so you may have noticed back with number 3 that sine of 30 degrees was the same as cosine of 60 degrees. And cosine of 30 degrees was the same as sine of 60 degrees. Why is that true? Well, that's true because 60 degrees and 30 degrees makes up 90 degrees. And that is the basis of cofunction identities. Okay, so cofunctions of complementary angles are equal. Cofunctions are just functions with their cos. So sine and cosine go together. Tangent and cotangent go together. Secant and cosecant go together. Those are cofunction identities. So the identities tell us that if we have sine of an angle, it's going to be the same as cosine of 90 degrees minus that angle. So back to this example. Sine of 30 degrees should be the same as sine of 30 degrees should be the same as cosine of 90 degrees minus 30, which is 60. So these two should be the same. So this is called a cofunction identity. So it says, here's a little typo, for each function value, find a cofunction with the same value. So we're given cotangent of 15 degrees. Well, what's a cofunction to cotangent? That would be tangent. So cotangent of 15 degrees should be the same as tangent of 90 degrees minus 15 degrees. So we just discovered that cotangent of 15 degrees is the same as tangent of 75 degrees. So this has the same value as what was up here, 2 plus √3. All right. Also, we have cosine of pi/6. Well, what's the cofunction that goes with cosine? That would be sine. So this should be the same as sine of, note, we have radians here. So we don't want to use 90 degrees. We want to use pi/2. Pi/2 is the same as 90 degrees, but in radians. So this is the same, pi/2 minus pi/6. Let's go ahead and simplify this by getting a common denominator. 6 would make a good one. So over here we would need 3. So sine of 3 pi over 6 minus pi over 6 is 2 pi over 6. And that equals a sine of pi over 3. So these are the same. All right, and so actually pi over 3 is 60 degrees, pi over 6 is 30 degrees. We saw this before, that these are the same.